Alright, let's take a look at a question regarding operations of functions. So here we have two functions, f, and we have a series of ordered pairs, 0 and 6, 1 and 3, 4 and 7, 5 and 8. And we have another function, g, which has an ordered pair set of negative 1 and 2, 1 and 4, 2 and 3, 4 and 8, and 8 and 9. Okay, so we want to determine the following. The first is the sum of the two functions, f of x plus g of x. Now, when you're adding functions, you have to add the same x values, right? So you add the y values of the same occurring x values. Here's an example. If I wanted to add f of 0, I'd have to add it with g of 0, except for the fact that there is no g of 0. So you need to look at anything that basically has the same x values, right? So in this case, I can only see 2 points that have the same x values, so I can only potentially add those 2 points together. So for part A, I can do f of 1 plus g of 1. So f of 1 here is 3 plus g of 1 here is 7. Oops, sorry, 4. And this is going to give us 7. Okay, so f of 1 plus g of 1 is equal to 7, or you can write this as f of g of 1 is equal to 7. Okay, we can also add f of 4 and g of 4 as long as the x values are the same. And in this case, we'll get f of 4 here is 7, g of 4 here is 8, we'll get 15. So f plus g of 4 is equal to 15. Okay, so you can actually get these points and plot them, and you'll actually get a different kind of function as the sum of these two functions. So the graph actually will look a little different. So it's a combination of these two functions, really. Let's take a look at part B. So it's the same rule for subtraction, multiplication, and division, right? For subtraction, f of x minus g of x, so you use the same rule, you have to keep the x's constant. So in this case, I can only subtract f of 1 minus g of 1. So if I do f of 1 minus g of 1, f of 1 here was 3. G of 1 here was 4. Whoops, was 4. Excuse me. So 3 minus 4 here is negative 1. And the other point that we can actually use here is f of 4 minus g of 4. And in this case, f of 4 minus g of 4 is going to give us f of 4 here is 7, g of 4 here is 8, and this is going to give us negative 1. Okay, so when you do write this out, right, you really want to include the ordered pairs. So in the first case, you know how we had f plus g of 4 is equal to 15. You want to write the point as 4 and 15. And we know that f of g of 1 was 7, so the point here is 1 and 7. So these are the new points of the f plus g ordered pair set. Okay, so you can write this down as 1 and 7, and 4 and 5. Sorry, 4 and 15. Whoops. Okay, so you can do the same thing for this, right? So in the f minus g set, right, you would basically get 1 and negative 1, as well as 4 and negative 1. Okay, so this was a negative 1 as well. Okay, so that's the two combined sets that we've looked at. Excuse me. Let's take a look at part C. So you have f of x times g of x. So you do the same thing. You do f of 1 times g of 1, which is basically 3 times 4, which is 12. And we can also do f of 4 times g of 4, which is 7 times 8, which is 56. Okay, so in this set, f times g, you can have the points 1 and 12 and 4 and 56. Okay, so that's how we can combine functions into a variety of different operations by using a variety of different operations.